So 7.2. So we're going to be looking at arithmetic sequences and their series. And then we'll learn a different type later on in this chapter called geometric sequences and geometric series. Once again, we'll be learning about their general terms and how to add them up and so on and so forth. So, pretty cool stuff today. Here's our objective. Those of you taking Cornell notes could write down the objective. Students will be able to study arithmetic sequences and series. So, how can you tell if a sequence is arithmetic? So, interesting secrets will be revealed. Anyone taking Cornell notes? Okay, so let's go ahead and get going. And so in an arithmetic sequence, the thing that makes it an arithmetic sequence is a common difference. It means you subtract. And they use a letter for common difference as D. I know it's hard to imagine that they would use letter D there, but that's what we do. As math types, we like to use letters that kind of remind us of what that word means or what it stands for. So we use the letter D for difference.
Wait.
Back up. What are you writing down something? Oh, okay. It's a common difference. Now you have to make sure you calculate that common difference correctly. That's where people make mistakes. So when we're looking at a common difference, we have to subtract correctly. So here's how it works. What you do to find the common difference is you pick any number basically in the sequence, like this one right here. And then what you do is subtract the one right next to it. You subtract the previous term. So 11 minus 6 is equal to 5. That is what we'd call our common difference, if there is one. Okay, it may be that there is not a common difference. Okay, so naturally you can't pick this one because there's no previous one in front of it, right? But you could pick this one and you get 16 minus 11 and you get 5 again. You see, and if you pick this one, well then you'd have 6. What you do is subtract the one that's in front of it. Minus 1, that's equal to 5. And so you can see there is a common difference. Okay, and if there is a common difference, then we say it's arithmetic. So we're going to say arith.
There's shorter way to say that. Right.
Any suggestions? I could maybe abbreviate like that, and I'd be okay. Arith. I'd probably get it. How about this one? Is there a common difference? Well, if you look at the difference between these two, you'd say there's a 2, and the difference here is a 4, and so you're going to say no. No common difference. No common difference, therefore not arithmetic. Now, it might be some other special one, but it's just not arithmetic. I mean, we're going to learn about some other ones in this chapter as well. Okay, so these are little tricks of the trade, so we want to be able to spot these things. And so the first types of problems you're going to have on your study guide and also for homework are these types, where you just look and check whether there's a common difference or not. Okay, well now we move on to the next a little bit harder problem. Okay. It turns out these rules are fairly easy to determine. Now remember, on the previous assignment we had to kind of guess and check a little bit. But you'll find that there is a common difference, then it's real easy to come up with the rule. In fact, we've written it for you. There's a real quick way to do it. You can write out the rule. By the way, if you have your study guide, I would write this rule somewhere on like the top area of your note of your study guide. It's probably also written in your study guide somewhere. Oh, it is. You'll notice it's like in that first paragraph there. So it is written there for you. But you know, I would say if you memorize it, even better. So there's a real tricky, there's a real easy formula to figure out what the general rule is. What's there though? In order to figure out the general rule, you need a couple things. Number one, you need to know what the first term is. This is the first term in that sequence. You also need to know this one. This one is the common difference. So if you have these two pieces of information, you can get the general term. Now, you don't determine what n is. That's part of your rule at the moment. So leave this one alone. Okay, just leave that one alone. That's supposed to be part of the formula. Does that make sense? So let's try this out. Now it is in your study guide, so we'll try to practice this, okay? So write a rule for the nth term of the sequence. So, and then they say once you get the nth rule, find the 15th term. Alright, so here's how this works. I think we said that a sub n is equal to the first term. I'm going from memory here. See how good my memory is? Let's see if I get it. I think it's n minus 1 times d. Is that right? Yeah. Pretty good for an old fogey. Okay, so what do we need to know? We need to know this one. That's easy, right? Isn't it right here? There's the first term that's in the sequence. So that number goes out in front. So we put a 4 here. Now, n minus 1 we don't know, so we'll just leave that in here, n minus 1. And then we figure out what the common difference is. Well, look, if you just subtract those two, you go, well, the common difference is 5, and you can check it real quick. It's 5, right? Common difference is 5, and you check there, the common difference is 5. So 5 is your common difference. Okay. So now what we do is just clean things up a little bit. We could actually leave it the way it is, but most of the time we just multiply this out a little bit, clean things up a little bit. We could also multiply by this 5. So, oh, hang on, I have a mistake here. I was wondering, something looked funny. Hold up here. I didn't copy it right, did I? So, let me fix this. This is 4 plus n minus 1 times 5. Okay, so now we take this 5 and distribute here and distribute here. And that gives us 4 plus 5n minus 5. Okay, and we could combine like terms here. So we get a sub n is equal to 5n minus 1. Is that right? Okay, so we see how that works. There's the general term. What's kind of nice about this is that once we have the general rule, we can find the 15th one. We don't have to list them all out. Does that make sense? You don't have to keep doing this, you know, Why did you do this first? Because not all sequences are arithmetic. Sometimes there's some other rule. Remember, you had some rules like n squared plus 1. Well, that's not arithmetic. and then you had many others. This is a special sequence that comes up. It actually comes up frequently in business. So this is one worthy to spend some time with. Okay, so now we're ready to do the second problem. Okay, so what's a sub 15? Well, whatever is here, you just put in for n right there. So why don't you finish this on up? Go ahead and take a moment. You don't have to have me do everything for you, right? And finish this up. 5 times 15. That's what? 75 maybe? 75, 15, and 15 is 30.
75.
Plus another 15 is 45, and then 60. That's 4 15s. And another 15 takes you to 75. Well, then you subtract 1. 74. 5 times 15 minus 1. And now you know the 74th. Okay, so any questions on that one? Okay, so let's do another one here. When you're doing an arithmetic sequence, yeah.
What if there isn't a common term? What do you do?
What if there's no common difference?
Yeah.
If there's no common difference, then it's not arithmetic. And so that's what we state. We say it's not arithmetic. If it is arithmetic, then we can find a rule using this little formula right here. Okay? Well, so let's check and see if there's a common difference. This time the sequence is going down, it looks like, or getting smaller. The common difference here is not positive 8. It's negative 8. You see, if you take 52 and you subtract 60, you get negative 8. Okay, and if you do the common difference here, 44 minus 52, once again, you get negative 8. Yeah. I suppose. So there is a common difference. And so what we're going to do is write out the common difference formula. And we're just going to plug in things. I recommend writing the formula every time until you have it like memorized. And I would recommend, just based on my own experience, I always felt more confident doing my homework and test when I had things memorized. I knew it well enough. Okay, so the first term in the sequence goes right here. That's pretty easy, right? And then what? The common difference we said was negative 8, so that number is going to go in here. And then we just do some basic algebra and simplify this. Okay, so let's wrap this up. I get a sub n. The general rule is 60. And then we get n minus 1. We have a plus sign. Times negative 8. Well, I think that simplifies a little bit. Is a 60 minus 8n, and then we're just distributing over here. A negative times a negative gives me a positive though, so I get positive 8. And so that's the same thing as a sub n is equal to 68 minus 8n. Okay, so any questions so far? Now what we need to do is find the 15th term. So we're going to say a sub 15 just means put 15 in right here, right? And so we get 68 minus 8 times what? Times 15. And so I'm just going to use my trusty calculator. What is it?
120.
It's 120? I don't think it's 120. Tell me why. What's 8 times 15?
120.
8 times 15 is 120? And so that's a negative number. The negative number is bigger than the positive.
Oh.
So I know this is not a positive answer.
Negative
Does that make sense? I get negative 52.
Wait, oh, you didn't, yeah, I thought you did, it's negative.
Yeah, 8 times 15 is what?
Negative 120.
This is negative 120. So what's 68 minus 120?
Negative 52.
Yeah.
Oh, I know.
Okay, so be careful. These are easy, but...
Oh, but you were asking what's 8 times 15.
Oh, I'm sorry. I'm sorry. That was my mistake then. Stupid. Moongoon. Okay, so I think we're at a good stopping point at the moment. Not for the whole lesson, but I think what I would recommend is that you do some of your study guide now. I think what you can do is numbers 1 through 4, and then you could do 5, 6, and 7. Okay, so I'm going to give you about 10 minutes to do that, and then we'll resume the lesson. Okay, so here's another problem that's related to the formula that we just had, and sometimes you have to work backwards a little bit. Sometimes they don't spoon feed you and give you all the pieces of information you need. And so, take a look at this one. This time someone told you the 19th term of a arithmetic sequence is equal to 48. They also tell us that the common difference is 3. Now they want the rule. It's like, okay, why do you have to make things difficult for me? Well, first of all, it's not that difficult, because we know the general term, right, already. We know that no matter what, if it's an arithmetic sequence, it's going to look like this. We need to know the first term, and then after that we're going to add, what, n minus 1 times the common difference. So just like most things in algebra, if we know everything but one of these, we can figure out something. And it turns out they gave me the common difference. So I know that one already. So what we can do is erase this and put 3 here. Now remember, we normally want n in the formula, but right now we don't know what the first term is. What we know is the 19th term. Well, if that's the 19th term, then what's n? What's n? If I know n, then I could probably solve this. N is the 19, right? When you do a sub 1 and you do a sub 2 and you do a sub 3, this is your n value. That's n at the moment. So the thing to realize is, well, okay, this 19 is n. Alright, now part of the mystery solved for me then. This 19 needs to go here. Now, what's this 48 then? That's the a sub n value at that moment. So, that's what it's equal to, because normally what you'd have is a sub 19 right here, right? And then you'd have equal blah blah blah, right? Well, it's equal to 48. So what you can do is take let me use a different color here. You can take this 48 now and you can substitute it in right here. You see? Since a sub 19 is equal to 48, you're going to replace this one with 48. And that will allow us to solve for a sub 1. And because we know n is equal to 19, and then we subtract 1, multiply that by the common difference, which is 3. Okay, well, with some basic algebra skills, you can solve this equation, I hope, for a sub 1. So if I do this, I get 18 times 3, right? And 18 times 3. By the way, how come I didn't... Oh, I was going to ask a different question. Never mind. 18 times 3 is 54, so this is 54. And I'm just going to continue using my basic algebra skills. And I'm going to solve for a sub 1 by subtracting 54 now. Subtract 54. Oh, need some glasses here. I should have 54 there, right? Minus 54. Okay, so 8 minus 4 is 4. Uh-oh, this is, I think, a negative number. Hang on, I don't know if I subtracted that right. I'm used to doing the bigger number on top. So let's see, 54, that's the bigger of the two. And since they're opposite in sign, I'm going to subtract 48. And well, the negative goes with the bigger number, right? So let's subtract here. That's 6. It's just 6, isn't it? Negative 6? Huh? That's negative 6, right? Negative 6? Well, so my very first term that would have started off this sequence would have been a negative 6. Okay, so the general term then is what I'm after is negative 6. And then what do we do? Plus n minus 1 times 3. Right? Now we could distribute this and simplify it a little bit further. Okay, I'm getting rid of this diarrhea green color. It's easier to remember what the color is, right? Anyone know what this color would be called? Just simply green. Alright, diarrhea green. Or cow pie green, huh? Alright, so plus 3n minus 3, right? We distributed. And now what we do is combine these two, right? Please tell me you can do that. It's negative 9, right? Plus 3n. And there we have our general term now. Now, by the way, once we have the general term, then we can find any of the terms of the sequence, right? So did they ask for some other term? They said write a rule for the nth term. Alright, so working backwards is a little bit harder, right? You have to do a little bit of algebra. Now what they asked though is they asked for us to graph the sequence. So let me show you what that's about. You see, and they're trying to give you an idea about how the graph looks. By the way, do you guys think this will be a straight line or a curved line? If I start graphing the data, what would make you think that it's a straight line? Any ideas about how you would think it's a straight line? Versus a parabola? A parabola, we saw it was a curve all over, right? So do you guys think this is going to be a straight line or a curvy line?
Straight, because it's a negative to positive.
Say again?
Straight.
Straight because of what?
It starts from a negative.
Starts from a negative?
From a negative 6 up to like 48.
To positive? Well, I was hoping someone else would see something that they've seen before. What do lines look like? What's a general equation for lines? Y equals what? Mx plus b. Do you guys see anything in this formula that looks like an mx plus b in here? Yeah, isn't that a linear equation? So this better look like a line, right? This would be your m, right? That's the same thing as like that number. And this number is like your y-intercept, right? Over here. Make sense? However, there is one difference between lines and these. I want to show you the difference. Okay, it does look like a line, but it's actually not a line. Let me show you what it is actually instead. Okay, you ready for this? Please understand the difference. Okay, so if I do n equal to 1, we've already seen that if you put a 1 in here, you get a sub 1 is equal to negative 9 plus 3 times 1, right? Which actually equals negative 6, right? So let's say I'm going down by 2's here. Negative 2, negative 4, negative 6. And so I'm going to go, this is going to be a positive 2, positive 4, positive 6, positive 8. And then at my x-axis, I think I'll go up by 1s. 2, 3, 4. Alright, so let me graph my first point then. My first point on my sequence, arithmetic sequence, series here, sequence, would be right here. Does that make sense? That would be what we call the y-intercept. Okay, my next term is a sub 2. Well, that would be equal to negative 9 plus 3 times 2. Well, I think that gives me negative 3, right? So when, oh, by the way, did I graph this spot right?
No.
No. It's supposed to be at 1, right? Oh, what a bozo. Alright, so that's not quite right. This was at n equal to 1, so it should be right here. And then when n is equal to 2, I get negative 3, which would be right here. And then when I do, well, let's just do a sub 3 right here, okay? A sub 3 is equal to negative 9, right? Plus 3 times 3, right? That's 9, negative 9 plus 9. That's equal to 0, right? So you're crossing right there. Now, do you see the difference between these sequences? The sequences only have these dots as their solution. A line, on the other hand, would have the entire line be the solution, right? Do you see the difference? Lines have all real numbers as their domain. What's the domain on these guys? Only the counting numbers, right? So that's one thing you should realize, is that the domain that we're talking about, the domain value, I'll spell it right here. These are the x values that go in. They're equal to 1, 2, 3, 4, ... These are positive integers. Positive integers only. Okay, integers. Okay? So the domain is different for a sequence than it is for a linear function. But they are similar, right? I mean, they do have a slope and so on and so forth. Okay, so to graph these, make sure that you're just putting dots in here. It looks like a line, but don't connect the dots, because there is no 2.5 for an arithmetic sequence. Does that make sense? There's no 2.1. There's no 2.156. So there's only like a 2, a 3, a 4, and so on. So they only have dots in their graph. Is that clear to everyone? All right. Well, let's look now at this problem. You've actually done a couple. Well, this is another one of those working backwards ones, where you would start off with a sub n, right? And so you'd have a sub 1, then you'd have plus n minus 1 times the common difference. Okay, so we're told the 27th term. And we're also told the common difference. So once again, this one will go in here, okay? 27 is what the n value is, okay? And this goes in over here. And so, once again, we can solve for a sub 1. Okay, so I'm going to put 263 right here. By the way, I would recommend copying down this example also. If you know, you'll have more of these on your book assignment. 27 minus 1 is actually 26, right? And the common difference is 11. Alright, so 26 times 11. This number is 286. And so we just use our baby algebra skills to solve for a sub 1 by subtracting. And we get a sub 1 is equal to a negative number again, right? Let's see. 263 minus. We get negative 23. So once you get that, you can then write out the general term. A sub n is equal to negative 23 plus n minus 1 times the common difference, which is 11. And of course, we don't want to leave it like this. We want to simplify it further by distributing this here. We can clean things up a little bit. Negative 23 plus 11n minus 11. And then these two combine, of course, to give us negative 34. Is that right? Plus 11n. Alright, so then there's our a sub n. That's about as hard as these problems get. Now, we want to be able to do the last couple problems on your study guide, so let's get to the sum. Well, if we're trying to add these things up instead. Let's try the sum formula. What are we adding these things? Here's the formula again. It's written on your sheet, and I would recommend writing it down each time. If you're trying to add up an arithmetic sequence, you can find the sum. And these formulas work just like the arithmetic sequence ones. So let's try that out. So let me see if I can write this down. It was S sub n is equal to n times what? You gotta know something here. What do we need to know? There's a fraction or something involved, right? Isn't it on your... you gotta know the a sub 1 term again, right? And then you need what? A sub n. You need to know the a sub n term. Okay. And then you need to divide that one by 2, right? Well, let me give you some tips here, okay? You guys ready for some tips? This one is the first term. First. This one in this case will be the last term. The last term. Okay? Can we figure those out?
Yeah.
We can, because this is our summation notation stuff. So if I wanted to find out the a sub 1 term, I would just put this one in for I there, and I can find out the first one, right? And so that's going to be equal to 3 plus 5 times 1. And in this case, I get 8. Is that right? So I found out this 8 goes in right here. Now, since this has an ending point of 20, that's going to be my last term. But I need to plug it in. I need to plug the, you know, this thing cycles through. So a sub 20 is going to be equal to what? Well, I gotta put the 20 in right here, right? And so then I get 3 plus 5 times 20. Okay. Well, 5 times 20 is 100, right? And so 100 plus 3 is 103. Okay, so I have part of this formula figured out. And so I have that one and this one, right? So I have 8 plus 103. I'm going to divide that one by 2. And then what? Huh? And then I need to multiply by n. Well, how many terms are there? If there's a 20 on top, isn't this value what n is? Right there. So I need to multiply this one by 20. And that also means that the sum of those first 20 terms is going to be equal to this right here. So let's check this out. 8 plus 103 is 111, right? Divide that one by 2, and then multiply that one by 20. That's equal to s of 20. And then what? Well, the 2 cancels off with the 20. That gives me 10, right? And then 10 times 111 is 1110. So the sum of those first 20 terms, if you were to add them all up, is equal to 11110. And that looks like answer C right here. Now, by the way, now if you want to do this by hand, you can. The first term would have been 8. Okay, and then you would have added the next term was 2. The next term would have been 13. And then the next term would have been what? 18. And then 23. And then you can add those first 20 terms. And believe it or not, if you do that, it's going to add up to that. So, probably what you could do now is use this formula and finish up those last 2 problems on your study guide. So we'll stop here.